Today we want to review the tools that we have for solving oblique triangles. The first rule, the sum of the angles is 180 degrees. What this means is that, the reason I list this first is that as soon as you know two angles, you need to subtract to find the third angle. Our goal is to get more information. The easiest thing to do is just subtract to find a third angle. So that's the first thing that we should always do. Don't always have that option. So the next tool that we have is the generalization of the Pythagorean theorem. So the law of cosines is the general Pythagorean theorem. And what I mean is that the law of cosines becomes the Pythagorean theorem if one of the angles is 90 degrees, because cosine of 90 is equal to 0. But we can use the law of cosines to find an angle. So say I'm going to do gamma because I always do gamma. Gamma is the cosine inverse of c squared minus a squared minus b squared all over 2ab. So we use the law of cosines if we have all three sides. We can use the law of cosines to find an angle. We can also use the law of cosines if we have two sides and the included angle. So I can say that c is the square root of a squared plus b squared minus 2ab cosine gamma. So another way I think about this is that we use the law of cosines when we're looking for an opposite, works for sines as well. It depends on what we have. So here we have the Pythagorean theorem. If gamma is 90 degrees, cosine of 90 is 0, and this minus 2ab cosine gamma, that term drops out. But if gamma is a 90-degree angle, then c is called the hypotenuse. And so this is how we would solve for the hypotenuse. So use the law of cosines for the SSS case and the SAS case. All three sides, we can use it to find an angle, or two sides and the included angle. We can use that to solve for the third side. We also have the law of sines. The law of sines is for when we have two angles and a side, two angles and the side opposite one of the angles, or two angles and the included side. If we have two angles, we have three angles. So before we're even using the law of sines, we should subtract to find the third angle in this two angles case. And then there's the side-side angle case, which is the ambiguous one. So this is two sides and the angle opposite one of those sides. Different than the law of cosines, which is two sides and the included angle. This is two sides and the angle opposite one of those sides. So the law of sines, it says that the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. The ratio of the sine of an angle to the side opposite that angle is constant in any triangle. That means the sine of alpha over A is the same as sine alpha over B, and that equals the sine of gamma over C. We can see why we need two angles and a side, because if I have two alpha, beta, I need A or B, and then I can use these first two parts of the law of sines. Notice that if I have side, 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 I don't get to use the law of sines. I have A, B, and C. I don't have two parts of this equation that I can put together. If I have side A, angle beta, and angle gamma, I can subtract to find angle alpha. And so then I can use sine alpha over A to find B and C. So we need to be able to use this to solve for a side A, or say an angle alpha. So if we solve for a side, I want to solve for us. Maybe I should solve for an angle first, because I did an angle over here first. But then it wouldn't go with the AAS case. Solve for A. A is going to be B times the sine of alpha divided by the sine of beta. So we just take B sine alpha divided by sine of beta, and that'll give us A. And then we just need to there's 3 other versions of this. A is going to be C sine alpha over sine of gamma. And then we'll have for B, we could solve for C in 2 different ways. So there's like 6 ways we could solve for an angle, a side here. Just need 1 so we can do permutations on it. We can also use the law of sines to find an angle. So the angle alpha will be the sine inverse. So the sine of alpha will be A times the sine of beta divided by B. And then since we're looking for an angle, we have to use an inverse. Notice that in all cases, there's a B over sine beta or a sine beta over B. So the matching stuff is always going to be in the fraction somehow. And then we just have to do permutations. Beta can be sine inverse of, I lost track of which one I said. Just like with the law of cosines, and I wasn't able to recover. Just like with the law of cosines, we should be able to permute alpha, beta, and gamma through. And we can have alpha with B and beta, or alpha with C and gamma, or beta with A and alpha, or beta with C and gamma. And then 2 more, gamma with A and alpha, gamma with B and beta. 3 different ways. Okay, so we got the law of cosines, and we've got the law of sines. The law of sines, if one of these angles is a right angle, like if the sine of gamma is equal, if gamma is 90 degrees, then the sine of gamma is equal to 1. So we have sine of alpha over A is equal to 1 over C. And so sine of alpha will be A over C. And so this is like the generalized trig ratios. Any questions? All right, so I did a lot of talking about non-trig related things. This is our summary of things, but the important thing to recognize is that this is just an expansion of what we already knew. Solving right triangles is a subset of solving oblique triangles. We've just generalized things. Any questions? All right, so your job now is to jump on, catch the quizzes. If you've completed all those quizzes, then you're waiting patiently for me to grade them so that you can do any revisions that you need to do. And I think I want to put up another quiz, some more quizzes. I got to see how they're going to play out. I might want to take care of something in a discussion instead. So there might be another graded discussion. So keep an eye out for any new graded things. Open up your grade book on the Canvas to see if you're missing anything, and then go do that thing. All right, that's going to do it for today. That's going to do it for today. I will see y'all on Wednesday. Everybody have a good couple of days, and thanks for playing.